And if I was to, there are many ways I can represent this forcing function. One method is, if I look here, this form of excitation could be very general in the sense, f t is equal to f e to the power j omega t. Okay. And then similarly, I will have a response x t is nothing but x e to the power j omega t. So, by substituting such an equation in the equation of motion, I will have this form x by f is equal to 1 by minus m omega square plus k plus j omega c. This is one form of the response to the force is given by this, where m, k and c are the system characteristics. So, if I was to find out the magnitude of this quantity, this is a complex quantity. So, and this is known as the frequency response function. And the magnitude x by f is given by 1 by k minus m omega square whole square plus c omega square, the square root of it. Okay. And there will be a phase difference between the response and the input, and that will be given as the phase difference, nothing but tan inverse of c omega by k minus m omega squared. Okay. Now, this frequency response function, which I had just denoted in a manner as x by f, that means I have measured the response as a displacement and the forcing function as f. And then there are many ways I could also have represented them. For example, it could have been x dot by f, it could have been x double dot by f. Okay. And then there are some names associated with it. For example, you all know f by x is nothing but stiffness, then f by x dot is the damping, f by, or highlighted as small x dot is nothing but the mass, and the inverse of this x by f is nothing but the compliance, and then we have x dot by f as the mobility, x double dot by f as the impedance. Okay. So, these are the same things represented as different ratios depending on the convenience which we have. So, to this equation of motion, if I have If I divide both sides by m, I will end up with okay, and then I will have, if I denote two new terms k by m as omega n square, where omega n is the circular natural frequency and zeta is the damping ratio. So, this equation or x by f could also be represented as one by 1 minus omega by omega n square whole square plus twice zeta omega by omega n square and to the power 1 by 2. If I again denote omega by omega n as r, so the frequency response function is given by sorry 2 zeta r whole square, and this is known as the dynamic magnification factor. And looking at this equation, okay, there will be a x by f by k actually. In fact, I take it back, I just did a typo here, so make a correction, it is f by k. So, in fact, I was to write it again. So, x by x naught is given by 1 by 1 minus r square plus twice zeta r whole square, and this is what is known as the dynamic magnification factor, where x naught is the static displacement and x is the dynamic displacement. So, if omega is equal to omega n, resonating conditions will have r equal to 1. So, this is going to disappear and I will have a x by x naught as 1 by twice zeta. Okay. So, you see this displacement actually depends on the forcing frequency, depends on the damping.